Hello all. Today's video is regarding one of the project which I have been working on for quite some time. So I call this project as container manager. So you will basically understand what this particular project is all about. In the recent trend, what we are seeing is containers are actively becoming part in the SDV transformation of vehicles. So mostly these containers will be catering for SLA, SLB and QM applications. SLC and SLD mostly will still be the old way only. I don't see it being in the form of a container anytime soon, at least in the near 1 to 2 years. So if we speak about any container manager, so what I have observed is irrespective of what application you are building or what your use case is all about, it basically has eight fundamental uh, building blocks or modules as such, which basically repeat as per the I mean which slightly modify as per the use case, but they stay constant throughout. So the idea behind this particular container manager project is to create a template which is basically catering to these particular use case of managing containers using a application which is C++, which is what mostly is used across automotive space, which caters to some eight standard requirements. Okay. So if at all you see in this particular image, uh, we are discussing about what to say, the container manager, which is the centerpiece over here. Okay. So the job of a container manager is to basically get information from another application or from the user, maybe via a UI, regarding the deployment or what to say, or to start, to stop, to run any of the container application based on request. Okay. Now say there is this particular container manager, there are two ways of actually triggering it. So one is via you get an auto trigger from your cloud, from the OEM's cloud, saying that there is a new application available, which you can basically download and you can run in the HPC or TCU or whatever device, whichever you are targeting. Or there could be another application which is basically triggering this particular container manager to spawn or to stop or to update any of the running containers. Okay. Now if you take the use case, if you consider any of this use case, so what actually happens is the particular container manager can be triggered via some standard set of protocols. Okay. And now the incoming information could be a JSON data or it could be a protobuf data. Okay. And the incoming data could be secure or it could be a plain text. Secure in the sense like an encrypted one. Okay. Now the once this particular container manager receives this particular data, then it has to forward it to a container runtime, and the container runtime could be anything. It could be Docker if at all you are simply experimenting. It could be K3s if at all you are experimenting with some orchestrator, or it could be Podman, which is actually being used in automotive space right now, or it could be something like Bluechy or Nchaos or anything else which are frequently designed in the automotive use case perspective. And the commands which basically go from this from the container manager to the container runtime could be a CLI command if at all you are prototyping. Say you want to get the list of containers which are running, you can simply do a system call of docker ps-a, assuming your container runtime is basically Docker. Or if at all you are looking for a production grade application, in that case you will basically do a REST call to the socket file whichever is available, say Podman, Docker or whatever it is. And once you basically do this particular request, you basically write whatever updates or whatever log, whatever data you have in a database. So you can have your own custom database, or you can have some of the standard database like Redis or anything of such kind. And whatever is happening, whatever is going around, you basically log it. So that is where the logging mechanism comes in. So we can have a glog which is standardly used, or you can just ignore logging if at all you're doing for any prototyping and you just want to print out. Yeah, you can switch to a cout, std cout. And at the same time, you can you actually even need to have a health monitoring of this particular container manager, where it sends a heartbeat saying that it is live and it is healthy. So these are some of the 8 building blocks which are basically required for any container manager to run. And the whole idea behind the project which I have worked on is to generalize these 8 blocks as much as possible, so that any developer can pick this particular uh, repository and customize it or tailor it for his own requirements, so that he can actually build up a production system for his use case. So it's a template which is scalable in nature, which provides you a lot of flexibility, but it doesn't provide you an end goal like how a Docker runtime or how a Podman runtime runs, because there you basically have an end goal. Like using Docker, I can basically spawn a container. Okay, but over here we are not solving any such use case. We are basically standardizing what to say, an architecture flow which can be scaled or which can be tailored to your use case, and it is designed keeping flexibility in mind. So that is the main idea over here, and it is completely written in C++. Okay, 17, C++ 17. So yeah, so this is basically the description of the particular container manager. So the link is below. So here you can see that it is written on C++ 17. As of now, it supports REST protocol, MQTT, message queue, dbus. The gRPC is planned. As of now, the gRPC, the proto version which I am using is 3.6.1, and it supports as of now CLI and the API which I have discussed. And the incoming data types could be JSON or protobuf. These are generally used, and I think this should be good enough for any of the automotive use case. And you can have the option of encryption or doing whatever it is. As of now, it supports AES and SHA-20. So this is the thing. And as of now, there is a custom embedded database which is by default, and there is Redis integrated into it. So all the design patterns and everything have been followed, so that it is scalable in nature. And apart from that, the build whichever we want to do is means you can basically do a custom build as per your requirement. So that I will explain you going forward what I mean to say by that. Now if at all you see, as I said, the protocols which are supported as of now are these 4. gRPC is in the roadmap, it is yet to be done. The data formats are JSON and protobuf. The encryptions are like no encryption, AES or SHA-20. These are the encryptions. The runtimes which is supported as of now is Docker and Podman. K3s and Bluechy, I have plans of developing it, going forward, integrating it. That is yet to be seen. The commands, basically we give a trigger, are basically by the command line or API, as I said earlier. Apart from this, you can even trigger the creation or deletion or operation deletion of a pod using a YAML also. So there is a master YAML template which basically fills the incoming data which is coming in form of JSON or proto, and then executes for creation or deletion of pods using Podman. The database which we are using as of now is Redis, and the custom embedded database. Logging, as I have explained, is glog, and there is actually a health heartbeat server which is created for this particular container manager, which has HTTP endpoints. Reason for having this particular HTTP server for container manager is to handle or it can be used for integrating any of the standard monitoring tools like Grafana or Prometheus or whatever it is going forward. Like the APIs are available, So you can basically use the open source tools and you can integrate into this particular container manager so that you can build nice dashboards also if at all you would like to. That's the idea behind this. And this is the architecture. So 4 different protocols as of now. So we have container manager in the center. So the 4 protocols receive either plain or encrypted data in the form of JSON or proto, send it to the container manager decrypts the data, and then it routes to the corresponding runtime, whichever it is, Docker, Podman, and either it is Docker CLI or Podman CLI, whatever it is, which basically triggers the corresponding runtimes, and the result is stored in the corresponding databases, whichever we have selected. Now this is the format of the incoming JSON and protobuf. So this is how it is. So the selection of runtime is what is written over here. So if at all I write Docker CLI, then it basically goes for the Docker ps -a kind of a commands. And if at all I go for Docker API, then it goes for the specific HTTP commands for the API for production systems. Okay, this is the operation. You can create, start, stop, restart, delete the containers based on this particular operation. And this is the container parameters, like the container name, the CPU, memory, etc., whatever it is, the image name, everything, the restart policies, everything. So the JSON, so the proto equivalent of this particular JSON is over here. That is what the protobuf file is all about over here. And as I was speaking regarding the YAML master template, so there is a YAML master template which is saved in a separate storage location, which gets the incoming request and it fills in the corresponding the placeholders, and then the corresponding YAML file is executed to create a pod, run a pod, delete a pod, whatever it is. So this is the idea behind it. If you can see over here, the parameters are not extensive. The parameters are simple in nature. Reason for having it in this way is this whole project is to showcase the capability and the architecture, not the functionality. So the functionality should be tailored as per the requirement of the user. So it is left out to the user on how many parameters he wants to use, and if he does the same thing for protobuf, it is his responsibility to create the corresponding protofiles and the corresponding headers so that he can tailor it to his necessity. The same thing goes even with the YAML file as well. He can add as many fields as possible as per his own requirement. Now I was speaking regarding the selective installation and selective build. What do I mean? So as of now, you have seen that it supports multiple protocols or multiple data formats, multiple encryptions, multiple runtimes, many things. Okay. Now say if at all I am doing a use case of a OTA where I am getting a data from the cloud or to the TCU gateway. Okay. And the incoming data is a protofile. Reason why protofile is more economical than JSON is protofile sends the same data in a shorter memory, so that it saves lot of cellular data, which reduces the cost for any of the car. So protobuf is preferred. So you get a encrypted protobuf data from the cloud onto your gateway, and the gateway simply forwards you that particular data to the container manager. So this particular mechanism of forwarding this particular data from the gateway to the container mechanism mostly will be via an IPC. So it could be a dbus or message queue or whatever it is. In that case, as of now, this particular project can support all of this. Okay. Now when we come to your use case, you don't need any of the, you don't need you don't need MQTT, it is not needed for you. You don't need dbus. You will be needing gRPC, you will be needing protobuf because the incoming data is proto. And you might not need Redis database, and the incoming data is encrypted. And anyways, this Heartbeat server runs all the time. So you don't need the MQTT, you don't need dbus because you're dealing with message queue, and you don't need Redis. Okay. Now This project is written in such a way that you can do a custom build as per your requirement, and the size of the binary also varies by the specific flags you select, and you need not install any of the libraries which are not needed for you. Means you don't need mosquito mqtt, or you don't need sd bus, okay, or you don't need something else. So that is how it is. Say in the same scenario, say instead of getting the data from a gateway, you are getting from your UI, okay, and from your UI, assuming that this entire host machine is safe and secure, the text will basically come in form of maybe JSON in plain text, no encryption, okay, and the incoming the data might be the same thing, maybe a message queue, not encrypted, no proto, nothing, it is simple plain JSON, okay. Now if at all you do it that way, then you don't need the protobuf, and you basically don't need the encryption. OpenSSL is not needed, okay. So the CMake is designed in such a way that you can do a custom build, and during that custom build only the targeted libraries are needed and nothing else is needed. So the design of the CMake and everything are done in such a way. So there will be a subsequent video of this particular project on how it has been designed, so that you will get a better understanding of what I'm trying to speak over here, okay. And now to test it out, that whether it is working or not, in over here you have a real application, okay, you have your own real use case. Now for your testing sake, you don't have any of the real application integrations yet, but you still want to do it. So for this, a simple Python UI has been created, which specifically does this job, which is this particular UI, where you can select which protocol you want, which runtime you want. Means it could be Docker CLI, Docker API, Podman CLI, Podman API, or Podman YAML. You can select the number of CPU, memory, the parameters, whichever you want to select. You can select the data format, it could be JSON or it could be proto. You can select the operation, whether it is creating the container, starting, stopping, restarting, removing, everything, and you can select the encryption whichever you want. It could be SHA-20, it could be AES, or it could be no encryption. So SHA and AES I have just taken it for an example, which generally are used, but you can switch with any of your what to say, encryption algorithms, whichever you want, as you wish. The architecture is flexible in nature because we have followed the adapter pattern, so you can basically switch with whichever algorithm which you need. And over here, this particular UI continuously pings the heartbeat sensor, heartbeat server of the container manager, based on which you get an indication of green or red. Green says that it is healthy, red means it is not healthy. So this ping goes once in a second, and there is a health button. So the moment you click on this particular health button, you will basically see the list of features which have been selected, what port the heartbeat server is running, what is the timestamp, and how long it has been running, everything, all those parameters are there. So this is for your own understanding and playing around with the container manager as per your wish. So this is the selective compilation which I was speaking about. Now say I enable all the protocols. So I enable REST, I enable MQTT, message queue, dbus. I enable the protobuf also. I enable encryption also. And in that encryption, I have selected SHA-20, and I have enabled Redis also. I make this CMake and I compile and I run it. So this is what I will see. This means I can see that the heartbeat server is on, which is on all the time. The HTTP server for container manager is available. So it means that any information can be triggered to this particular HTTP server, which is running at a different port number 5000. So each of these protocol is running in a separate thread of its own, so that the systems are stable. And say there is a kill of this particular container manager application for whatever reason, all the threads are safely shut down and closed, so that it is cleanly and nicely done. The heartbeat server runs in a separate thread of its own because it needs to run all the time. So here we can see that the HTTP server, message queue, message to MQTT, dbus, everything is on. The protobuf support is on. The Redis database is on. SHA has been selected. So based on this, we can see that it is encrypted, and you can see all the protocols are up and running, and even the heartbeat server, it shows that it is running at port number 8090. These are customizable ports. You can write whatever port number you want as per your requirement. Now say this is for testing, and you have figured out that you basically need only MQTT and you don't need anything else. You don't need any Redis, you don't need any secure algorithms and all, because you are in the you're getting a trigger from another use case to the container manager, another service. So in that case, everything is secure. You don't need any security and all. So you just in your CMake you enable only MQTT, nothing else. So in that case, you can see that only the MQTT subscriber is on. The JSON support, which is the default, is on, and there is no proto. When there is no proto, it falls back to JSON, and when there is no Redis database, it falls back to the custom embedded database, which is like a normal map inside the code in the stack. And the security has been disabled, and it says that there is no security at all, and the heartbeat server is, it is on as usual. Okay, so this is the UI, and this is actually the overall reason for why we have this particular project in the first place. What benefit it brings to anyone who wants to use this particular architecture and customize it for his own requirement, so that it can speed up the development process as much as possible. Okay, and in the subsequent video, I will give you a clear demonstration on how it operates, and then you will actually get a very clear idea with respect to how useful this particular project is. And this is licensed under MIT, so you can basically clone it, use it as per your wish, and there are no issues, no strings attached. So yeah, okay, fine. Thank you all. Thank you for your time.